This video is about monotonic arrays of rapidly increasing numbers. A monotonic array is an array where the numbers in the array are either consistently increasing or consistently decreasing. In this case, each successive number is greater than the element that came before it. Okay, so we begin by looking at the array of Ackerman numbers. What Ackerman numbers are, they are they're numbers. The base tells us how many steps are in the number. Like for example, first Ackerman number is just 1. The base is 1. Second Ackerman number is 2. That's the base to the second power. So that's 2 positions, the base and the exponent. And so 2 to the second power is 4. So second Ackerman number is 4. Third Ackerman number then is 3 to the 3 to the 3. So 3 positions, all 3s. First position, of course, is the base. The second position is the exponent. And the third position is the exponent of the exponent. So we have 3 to the 3 to the 3, which is equal to 3 to the 27th power. 3 to the 27th power is a pretty big number. It's in the, I'd say, septillions. Okay, so naturally the fourth Ackerman number is 4 to the 4 to the 4 to the 4. Okay, so we have 4 to the 4 is 256, so that reduces to 4 to the 4 to the 256 power. And that's the same as 4. The same as 4 to the 2 to the 5/12th power. Now, the 5 to the 5/12th power is a number that's larger than 1 followed by 153 zeros. So that's a pretty big number itself. And that's the number that's the exponent to the 4, the base, the final 4, which is, gosh, that'd be a challenge to calculate. And if we move to the next Ackerman number, the fifth Ackerman number, 5 to the 5 to the 5 to the 5, right? We have 5 5s, base, and a ladder of exponents. And that, I would say that from then on would be an intractable number if we wanted to calculate what it is in, if we wanted to calculate what it is in decimal terms. Okay, so so that's an idea of the array of Ackerman numbers and we see how it rapidly increases. But we can do better than this if we want to make increasingly large numbers, and we have something we call the enhanced Ackerman numbers. What happens there is we add factorial. So the first number is 1 factorial, which is still 1. The second enhanced Ackerman number is 2 factorial to the 2 factorial. 2 factorial is 2, so 2 factorial to 2 factorial is still 4. And for the third enhanced Ackerman number, we have 3 factorial to 3 factorial to 3 factorial. Now 3 factorial is 6. And okay, so therefore what this amounts to is 6 to the 6th to the 6th, which is a pretty sizable number, 6 to the 6th to the 6th. 6 to the 6th is, gosh, I believe that's 6 to the 776. I believe that's right. Which is still a very large number. There's a lot of factors of 6, And that is calculable. It turns out to be a pretty large number. All right, so of course then 4 to the 4 to the 4 to the 4 becomes all factorials, right? 4 factorial, 4 factorial, 4 factorial, 4 factorial. But that's not all we can do, right? We can do iterated factorials. In other words, we go back, we start out with 1 factorial again. This time we can do 2 factorial to 2 factorial iterated so that the base gets 1 factorial, the first exponent gets 2 factorials, and what is that? So 2 factorial, 2 factorial is 2, 2 factorial is 2, so it's still 2 to the 2, which is equals 4. When we go to the third one, 3 factorial to 3 factorial factorial to 3 factorial factorial factorial, right? 3 factorial, of course, again is 6, right? But 3 factorial factorial is 6 factorial, which is 720. See, already we have 6 to the 720, but there's still one more exponent, right? 3 factorial 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 is the same as 720 factorial factorial. Wait, so, yeah, no, so 3 factorial 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 is the same as 6 factorial factorial, which is 720 factorial, right? And so 720 factorial is a pretty large number, and that would indicate the number of factors of 720, which become the final, which when we resolve that becomes the final exponent for 6, and that turns out to be incalculable. So already we've gone pretty high in enhanced Ackerman numbers, at the third enhanced Ackerman numbers with iterated factorials. Now, besides this that I mentioned, there are other patterns possible. For example, we could double each level. So, for example, we start out with, 1 factorial for the base in the case of the third enhanced Ackerman number. Second is twice as many, 3 factorial factorial, and of course the third becomes 4 times, right? Factorial, 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 factorial. We're doubling at each level. So in the case of the fourth one, we have 4 factorial, and to the 4 factorial factorial to the 4 factorial 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 factorial, and the final one we iterated it 8 times. You see how quickly all of that could get out of hand. It just blows up. So basically the possibilities are endless.